What we're going to look at here are horizontal and vertical translations. Now these can be pretty straightforward, but I'm going to encourage you to use the function notation that I'm going to be using, just because when things get a little bit more complex, I think you're going to find it useful. Now, these are the examples we did in class, but I'm going to work them out in real time for you. So let's say that we have an equation f of x, or a function f of x equals x cubed plus 2x plus 6, and we need to move it down by 3 units. We need to translate it down. So what we had said is that if we move or translate a function down, let's just say our new function is g of x. I'm just defining that. So I'm going to say our new function is called g of x, and g of x is going to be f of x, but we're going to move it down by 3 units. So what we do is we subtract 3 from the function f of x. Now the 3 is outside of this function notation, so it's just whatever f of x is minus 3. Now that will translate it down by 3 units. What we need to do next is we need to substitute in what f of x is equal to into this notation. So everywhere I see f of x, I'm going to substitute in what f of x is equal to, which is x cubed plus 2x plus 6. So what that looks like is, now I'm going to put g of x is equal to, in these parentheses I'm going to put f of x. But now I'm going to write that f of x is equal to x cubed plus 2x plus 6. So now this is f of x minus 3, because according to our equation we need to move down by 3. According to the associative property, I can drop those parentheses. So I get g of x is equal to x cubed plus 2x plus 6 minus 3. And now I just combine like terms. So 6 minus 3 is 3. So I can write this as g of x is equal to x cubed plus 2x plus 3. So now g of x, as it's written, represents f of x translated down by 3 units. Let's look at the next one. So here they're telling us f of x is x squared minus 3x plus 4, and we need to move it up 4 units. So my new function, again, I'm just going to call it g of x. That's something that I'm making up and I'm defining, is equal to f of x, and if we need to translate up, we add 4. Now what I'm going to do is I'm going to, where I see f of x, put in what f of x actually represents into this new equation. So g of x is equal to, now I'm going to put in parentheses what f of x actually represents, so x squared minus 3x plus 4. So again, this is f of x, but I need to add 4 to it. And just like before, because of the associative property, we can drop the parentheses, so x squared minus 3x plus 4, and then there's another plus 4. So then we combine like terms. 4 plus 4 is 8. So our final answer is going to be g of x is equal to x squared minus 3x plus 8. So this g of x now should represent f of x translated up by 4. Let's look at one more example here. So we have a parent function f of x, a parent function f of x that was translated down by 5 units to give g of x. So let's just write that as it is. So g of x is f of x translated down by 5 units. So we need to subtract 5. Okay? the function g of x, so now they're giving us g of x, not f of x, is x squared plus 5x minus 4. So they're asking, what is the equation for the parent function f of x? Okay, so now I want to solve for f of x, and I'm given g of x. So what I can do in this case, since I want to know what f of x is I can add 5 to both sides. And so then I know that f of x is equal to g of x plus 5. And I'm given g of x, so now everywhere I see g of x, I'm going to plug it in down here. And so that looks like f of x is equal to, now I'm going to write what g of x represents, x squared plus 5x minus 4. And then I need to move that up by 5. And so I think you're getting the pattern. So f of x is going to be x squared plus 5x minus 4 plus 5. Combine like terms, you end up with f of x is equal to x squared plus 5x plus 1. So that's as simple as it is. So when you do a vertical translation, you either add or subtract to your original function to get your translated function. This is all occurring outside of the parentheses.